So hey guys, welcome to Shinobi Codes, and today I'm Anshul Joshi here to teach you recursions. Okay, so this is the first topic I have chosen, and why I chose this topic was because I felt that this is a very intermediate to advanced topic. Yeah, I don't want to teach like the bilkul extreme basics like if else statements and for loop and etc, but something which is like a little above and often neglected by people, and its importance is like beyond your imagination because you'll be using it when in every chapter ahead. So recursions, yeah, so I'll be teaching in C++. We have another guy, Bharat, he'll be teaching in Python. So if you are learning Python, then you should go there, and for C++ you should be here. So let's just focus on this topic called as recursions. Okay, so recursions. Let's just try to understand what does this word mean. So I googled this word and I found that the Google is saying the repeated application of a recursive procedure or definition means a certain definition is repeated again and again. There's a pattern you can observe. So this is the meaning of recursions according to Google. So this is a classical dictionary definition. So always try to connect coding things to real life. They just don't keep the words out of blue. There's a certain meaning behind it. And so we've learned the classical definition. Now let's see a simpler definition which my teacher taught me, which is in simple words, recursion is function calling itself. Now what does that mean? Well, for that first, let's before going into depth of recursion, I want to just make you capable to identify if there's this certain function is a recursive function or not. So I gave a sample layout of a recursive function. So if you are seeing a recursive function, you will always see a return, means a general function is there's a return type, then there's the function name, then it has some arguments and then some definitions, and then it finishes off with this following terminating bracket. But the interesting thing in recursive function is that it has, for example, like suppose a void data type function like Fibo is the name of the function, and it is taking argument int n. There are some statements, and again I'm calling Fibo of n-1. Suppose I'm just calling this function. Okay, so this is like I'm calling the same function again, like what happens when we call a function. Like there's a main, like there are some function definitions above, and then there's a main int main. So you start from here and then I call this function, so we go over here. Now there's an interesting thing over here. We are not going from main to the function, rather we are going from function to the function. Means function is calling itself. That is a recursive function. Like I have taken this picture which is saying that how does recursion work. So I went to int main and I found a recurse function. Okay, it doesn't have any argument, but as soon as I find a recurse function, I will search for its definition above and I will go to void recurse. Okay, it doesn't have a return type. Void recurse is where I am, and I followed the preceding steps and I again encountered recurse function. Now if I'm again I'm seeing this function, I will again go back to this function and with the arguments which are provided over here. So if you ever see a function and its name is again written inside with brackets, means then function is calling itself. This kind of functions are called as recursive functions, which form like the most important one of the most important topics of programming. Okay, so we have understood, we are now capable enough to understand what a recursive function looks like. Now I want you to write your own recursive function. For that I want you to understand this real life example. Or suppose you are a boy and you want a balloon, but your mother is very strict. She says that if it will take more than 5 minutes, then we'll leave. So a normal child, what will he do? Like suppose this is the child, then what will he do? He will go till the end and he will count number of people in this queue, and then he will return and say to mom, there are like 45 children ahead, so it will take much time, let's leave. Now what will a kid who knows programming do? What he'll do is he'll be standing here and he'll be just asking the person in front of him, can you tell me how many people are there in front of you? Now, suppose this kid is also a programmer and he also is very lazy kid. Again, what will he do? He will say, I don't want to work. I will just give my entire work to someone ahead of me. So he's going to call this kid drinking coke. Now this kid, again, he's also a programmer. He will also not do anything, lazy as we are. So the everybody will be just just the function is calling other functions, and at the end this is the person. This is the person at the start of the queue. And as soon as he'll get to know, okay, so you are asking me number of people ahead of me, no one is ahead of me, what will he return? He will say he will return 0. So this second last kid will say, okay, the person ahead of me has no one in front of him, so 1 plus 0 is the number of people ahead of me. He will say to the third last kid, okay, there are 2 people, there is 1 person ahead of me, the second last kid will say. And the third last kid will again use his maths. He will say, okay, 1 plus 1, so 2 people are ahead of me, I should convey this message to someone behind me. And this will go on, and at the end, lucky as this kid is, he won't move a single bit and he'll get to know number of people ahead of him. Now this was a very real life example of how recursion works. You'll be calling functions, you'll go to the end till the base case, and then the function will be returning. This is how recursion works. This was a good example how recursion can be working. How we can let me tell you a hack. How recursion works is that I don't want to solve anything. I will just give everything to someone ahead of me. I will give all the work to another function and I will wait for it to give me an answer, and then I will think. This is what a normal approach for recursion is. Okay, fine. So yeah, that's it. This is the first lecture. I just wanted you to feel from within what the recursion looks like. How can you identify a recursive function? Whenever there's a function definition, it's again, if you see something like that in that function definition, it's a recursive function. And I taught you the approach why we use it using this real life example. Okay, now I want you guys to interact with me, and I've always found that if you just brainstorm something, you'll learn better. So here is assignment number 1. In this assignment, I've given you a series where the first term is 0, second term is 1, third term is 1, fourth term is 2, fifth term is 3, and sixth term is 5. This series is a very popular series, and this series is called as Fibonacci series. So what I want you to do is, I just want you guys to find a recursive relation. A relation I want the nth Fibonacci number in terms of nth Fibonacci. Means you're getting this. First step I want you to do is find a pattern. Okay, find a pattern in this. If you have ever done mental ability things, so in mental ability you always need to find a pattern and you need to tell the other term. So here I am asking you, first step, please find the pattern, and second step, if you can, write function in these terms. Here this can be anything in terms of n. You have to generalize this for every n. If you can do this, then good to go. And just try to think about this for 5 minutes, and then see the next lecture where I'm giving you and solving this problem. I'm solving this problem for you guys. Okay, so that's it guys. Please like, share and subscribe, and I'll be solving many different kinds of problems, good problems, intermediate problems, easy problems for you. So don't miss any update, and thank you guys.